All right, welcome back. Today, we are diving into something really fascinating, a brand new release from Google. We're talking about a family of OpenAI models that are designed to totally supercharge machine translation as we know it.
Pretty much all of us have used Google Translate at some point, right? It's an incredible tool. It bridges language barriers for us every single day. But what if I told you that the tech underneath it all just took a massive leap forward? We're about to go way beyond what we're used to.
So, say hello to TranslateGemma. Now, this isn't just some minor update. No way. It's a whole new family of AI models. They're built on Google's super powerful Gemma 3 foundation, but, and this is the key part, they've been specifically trained and sharpened for one mission and one mission only, to be the best at translation.
Okay, so here's what's so clever about this. The original Gemma 3 AI, it's already a brilliant multilingual model. Think of it like a really smart person who's good at a lot of things, a generalist. But TranslateGemma, that's what happens when you take that brilliant generalist and put them through like an Olympic-level training program just for translation. It becomes a specialist.
So that really is the million-dollar question, right? How do you do that? How do you take an AI that's great at a bunch of stuff and turn it into an absolute world-class expert at something as tricky as translation? Well, it all comes down to the training. The folks at Google came up with this special two-step fine-tuning process. You can honestly think of it like a secret sauce, a recipe that's designed to take the model's translation skills and just boost them into a whole new league. Okay, so there are two main parts. Step one is something called supervised fine-tuning. This is basically where the model goes to school, It studies a gigantic library of really high-quality translations. Then you've got step two, reinforcement learning, and that's all about practice and refinement, getting constant feedback from experts to perfect its skills. Let's dig into what that actually means. All right, so that first step, the supervised fine-tuning. The model is learning from this really rich mix of data. A lot of it is actually synthetic translation data, so translations made by another really smart AI, plus some real human-translated stuff. But here's the secret ingredient, that 30% slice of generic instruction data. This part is so important. It stops the model from getting tunnel vision, from becoming so obsessed with translation that it forgets how to understand the bigger picture, the context and the nuance. Okay, now for step two, reinforcement learning. And honestly, this is where the real magic happens. The best way to think about it is like this. Imagine the AI is a translator, and it has a panel of expert judges looking over its shoulder, constantly reviewing its work. And they're not just checking for, is it right or wrong? No, they're looking at nuance, style, does it sound natural? And this is basically how it works. These judges are actually other really sophisticated AIs. And they don't just give a thumbs up or thumbs down. They give incredibly detailed feedback, scoring individual words and phrases on everything from pure accuracy to, does this just sound a little clunky? It's this nonstop coaching loop that teaches TranslateGemma how to create translations that really, truly sound like a person wrote them. Okay, so that's the whole training philosophy, the how. But the big question is, did it actually work? Well, let's take a look at the results, because the numbers here tell a really, really interesting story. Yeah, at the end of the day, that's what matters, right? How much better is it really? What's the actual payoff for all this specialized training? Well, the results are kind of staggering, actually. If you look at the big 27 billion parameter baseline model, its error score was 4.04. And with this metric, a lower score is better. You want to get that number down. So after the special training, TranslateGemma slashed that score to 3.09. That's a 23.5% drop in errors. That is a huge jump in quality.
That's impressive enough right there. But the research uncovered something maybe even more important. And it all comes down to efficiency.
And you got to listen to this, because this is maybe the biggest takeaway. The smaller, 12 billion parameter specialist model actually did better than the much, much larger 27 billion parameter generalist model. Let that sink in. That is a massive deal. It means you can get better quality translations while using way less computing power. That's a game changer. And this wasn't just some weird fluke either. The improvements were incredibly consistent across the board, across all the different model sizes. Didn't matter if it was the big 27B, the 12B, or even the little 4B model. They all saw this huge drop in errors after the training. It just goes to show how effective that secret recipe really is. But wait, there's more. The team found another totally unexpected benefit. Remember how we talked about that 30% of generic data they kept in the training mix? Well, it turns out that paid off in a really surprising way. So get this, all of those awesome improvements in translating text, they just sort of carried over to translating text inside of images. And what's wild is that the model got zero specific training for this. Its fundamental understanding of language just became so strong that it could start applying it in the visual world too.
And yep, the numbers back it up. When they tested on the Vistra image translation benchmark, TranslateGemma's error score was way lower than the baseline. It proves that these new skills are genuinely multimodal. So look, the technology is obviously super impressive, but maybe the most important part of this whole story isn't just what Google built, but how they decided to release it to the world. So let's zoom out for a second and look at the bigger picture.
TranslateGemma was released as what's called a family of open models. And what that means is that Google has basically just put them out there for everyone. They've publicly shared them so that researchers, developers, anyone who wants to, can get their hands on them, study them, and build new things on top of this amazing tech. And why does that matter so much? Well, because when you make tools like this open, you hit the accelerator on progress for the entire field. It builds a global community that can come up with new ideas, it makes the science transparent so others can check the work, and really, it democratizes the whole thing. It puts these incredibly powerful tools into the hands of people everywhere who can use them to solve problems we haven't even thought of yet. And that's exactly what the researchers said themselves. In their own words, the goal was to contribute a valuable set of open-source tools for the machine translation community. It's really about that idea that a rising tide lifts all boats. So that kind of brings us to our final thought here, and it's a really exciting one. By making an AI this good, this specialized, and this efficient, available to everyone, Google has handed the world a brand new set of tools. And it really just leaves us with one big question. Now that these language barriers are getting thinner and thinner, what new bridges are we all going to build?